The universe, an entity that fascinates and challenges our understanding, originated approximately 13.8 billion years ago with the cataclysmic event of the Big Bang, marking the beginning of space expansion. This event was not only the moment when matter and energy emerged, but also the start of a cosmic expansion that continues to this day. But what does it really mean that the universe is expanding? It is not just a simple drifting apart of objects and galaxies. In fact, the expansion of space implies that the very vacuum is creating new space between galaxies, forcing them to separate from each other. This phenomenon is not just a physical movement within a pre-existing space, but a transformation of space itself. The question that arises is as profound as it is mysterious. The universe is expanding without a visible end. But is there a boundary, a point beyond which expansion has never occurred? Or is it possible to conceive the idea of an edge of the universe? And if we were able to reach such an edge, what vision would await us? Moreover, one of the most intriguing questions that has captured the imagination of scientists and philosophers concerns the very fate of the universe. Into what is it expanding? At first glance, the idea of an infinite universe seems to exclude the possibility of a boundary. If the universe is infinite, then there could not be a physical edge, just as there is no edge on an infinite plane. However, the issue becomes more complex when considering that the universe might be finite yet without a physical boundary. This concept is similar to the surface of a sphere. If one moves in a certain direction long enough, they could return to their starting point without ever encountering a real edge. In other words, the universe could be finite, but its structure might be curved, like the surface of a sphere, where the idea of a physical boundary loses meaning. To reach a deeper understanding of what edge means in the universe, we must explore complex concepts, such as the very nature of space and time, and the possibility that the universe might be expanding in ways that challenge our traditional comprehension. One of the most fascinating questions concerns the speed of the universe's expansion. Can the universe expand faster than light? Einstein's relativity tells us that nothing can travel faster than light. But this does not necessarily mean that the expansion of space must adhere to this limit. In fact, the expansion of space is not a movement through space, but rather the creation of new space between objects. This means that space itself can expand at speeds greater than light without violating relativity. To understand this idea, one can think of the warping of space-time that occurs in the presence of a black hole, where the curvature of space can be so intense that nothing, not even light, can escape. Similarly, in the scenario of an expanding universe, space itself can expand faster than light without breaking the laws of physics. The expansion of the universe is not uniform but accelerated. In 1929, Edwin Hubble discovered that galaxies were moving away from each other and that the farther a galaxy was, the faster it receded. This phenomenon, known as Hubble's law, suggests that the universe is not only expanding, but that this expansion is accelerating. This acceleration was confirmed in subsequent years through observations of supernovae and the discovery of the mysterious dark energy, a force that appears to be responsible for the acceleration of expansion. The accelerated expansion implies that there are regions of the universe moving away from us so fast that their light will never reach us, even traveling at the speed of light. This means that the universe is much vaster than we initially imagined, with an expansion extending far beyond our ability to observe. When we look at the sky, we are not only looking into space, but also into the past. Every photon that reaches our telescopes has taken billions of years to travel the distance separating it from us. If we observe a galaxy 5 billion light-years away, we see it as it was 5 billion years ago, while a galaxy 10 billion light-years away shows us its appearance as it was 10 billion years ago. However, there is a limit to what we can observe, and this limit is imposed by the cosmic microwave background radiation, which represents the residual light from the Big Bang. This radiation, which originated when the universe was just 380,000 years old, is the farthest trace we can observe and marks the boundary of the observable universe. Due to space expansion, this radiation comes from a distance of about 46 billion light-years, even though its origin dates back to only 380,000 years after the Big Bang. The diameter of the observable universe is approximately 93 billion light-years. But if we could travel at the speed of light, could we ever reach this boundary of the universe? The answer is no, because there are regions of the universe expanding faster than the speed of light. This means that even if we can observe the cosmic microwave background radiation, we can never reach those remote regions. Furthermore, the cosmological horizon, which represents the maximum distance we can observe, is about 16 billion light-years, further limiting our visibility. This cosmological horizon acts as an invisible boundary, much like the event horizon of a black hole, beyond which nothing can escape. Imagine being able to reach the limit of the observable universe. What would you see? You would likely find a continuous panorama of empty space, with galaxies moving farther and farther away, becoming increasingly distant and blurred. The accelerated expansion suggests that beyond what we can observe, there are galaxies we will never see because their light has not had enough time to reach us. Moreover, beyond our cosmological horizon, there may be entire regions of the universe that are inaccessible, not only due to the speed of expansion, but also because the light from these regions will never have time to reach us. The universe, therefore, may be much larger than we can conceive. Looking back, if we could travel back through the universe, we might discover portions of it that have so far been invisible. The accelerated expansion could be hiding galaxies and cosmic structures that are still too far away to be seen. And although our visibility is limited, what we know so far suggests that the universe is not only immensely vast, but also continuously evolving, with mysteries that extend far beyond our current horizon. The infinity of the universe may hold surprises and discoveries that will forever change the way we think and understand the reality surrounding us. Thank you for watching. Leave a like and subscribe to the channel so you don't miss the next videos.